Hello. This is a demonstration of how the Python SFC models framework builds up a system of equations in a stock flow consistent model. What you see here, what I'm working in, this is the model runner, which is a prototype. It's available as source code in a different package. And first off, you select the model, you load it, and this is Model REG, regional, from Godley and Lavoie's Monetary Economics, Chapter 6. This model is fairly complex. It has 3 regions or countries where it's supposed to be one country. There's a central government with a central bank and a treasury, and then there's a deposit market, which is T-bill market. There's money, and then there's a tax flow. And then there's 2 regions, north and south, each which has a business and household sector. And then these are linked by a goods market, good, and then there's a labor market, lab. And the south has the same structure. The parameters are slightly different between the 2. And we now run. We can run all steps. We want to step through. And what happened is we've added sector codes. See, if we look at the equations locally, they're fairly easy to understand. The central bank, this is the demand for deposits. Demand deposits, the amount of T-bills it owns. And if F is its financial assets, and net financial assets normally 0, and so the demand for deposits equals the supply of money. In other words, the central bank's balance sheet all consists entirely of T-bills, and its liabilities and its money supply. So that's fairly easy to understand. And if we go into the sector equations, because we could have 2 central banks. So within the model, this one is only 1, but if you had 2 country, 2 currency, you have 2 central banks. So we need to distinguish them. And the way we do that is we stick a qualifier in front. These are the full sector codes. And so this is in the government sector, central government, CB, and then DEMTEC. So what we've done is all of these equations now have a prefix based on the full sector code. And we can then fix aliases. Aliases, we'll see one in a second. Run the next step. Okay, now we generate equations. See, now we go through each of the sectors, and we say each one generates equations based on relationships with other sectors. So far, the equations were either inserted manually or just a sector's autonomous relationships. Now we need to all the action is in the relationships between other sectors. So we'll do the tax flow. And see, these are the equations that were changed in the last step. And what we see, this here is the total tax paid, and so it's the tax rate times northern household income plus the tax rate times southern household income. So that's your total taxes coming in, and that increases government financial assets. So far that's all its income. And on the households are paying taxes, and see they're getting a subtraction from the tax. So now we're going to go to a goods market, and we run this. And once again, the government's affected because there's a demand for goods. This is government spending. This is in the north, so this is the government spending in the north. It has a negative income. It's paying out for the goods. And then the business sector in the north now has income because it's supplying goods. When we process, the labor market has a payout, which is the labor expense. And we have supply and demand, and these are equal. And then the household sector is also purchasing, so it has an effect on its financial assets. What we see here is there's also the there's exports from the south into the north, and so the southern business gains income. The size of its supply, it's the propensity to consume, mu times the household income. We don't have this code yet, or we didn't have it when this equation was built, and so this is an example of an alias, and that'll be fixed later to give us the proper code. And then we just keep going. So basically we just keep running steps. We see the number of sector equations up there is getting bigger, as we do all these processing. And then there's cash flows that are have to be added externally. We add in exogenous variables and we fix those aliases, and then now we do the final equations. And so here's all the final set of equations, and you'll see the difference between that and the sector equations is that all variables now have the full gov tree. They're the long name of all the variables. Whereas if you do this sector here, they're quite often using the short one. If it's if it refers to another sector, it has to be done. If we go in here, if you look within the sector, it knows what its own variables are, and it doesn't need to use the sector code. Now we'll just solve the thing. This takes a little while. There's 105 equations, although that equation count includes things like initial conditions and the constant parameters, so it's a bit overstated. And so now we've finished running, and so now we can show the graph. And the little bit of a bug here. Okay, let's hide. Like I said, it's a prototype GUI. And what we see here, these are all the various. What's happened? There's a change at period 5, and what's happened here? Southern good. This jumped. It's not very visible on this chart. I have to work on getting the plot scale a bit cleaner. This is the propensity to consume, and it jumped. So the south, that's about the only sort of external variable that changes, that the south imports more and has a negative effect on production in the south. This is the southern good, supply good. It started off in a steady state, and it drops because it's now importing more, and so the out of the total consumption, less is coming from itself, and so it drops. And this has this hits southern household after-tax income. The flip side, of course, is that the north also, this is supply labor. This is the amount of labor utilization, and it increased. There's a slight increase. I mean, the increase will draw on a little bit more exports, but it's not enough to offset the effect of themselves. So the increase in imports in this scenario, which is the same as in the book. I used the book for calibrating the model to make sure I was building the model correctly, and the south imports more, and so it has a drop in income. The north gets larger, it gets an increase. Anyways, that is it. Just wanted to demonstrate. I didn't want to discuss the model too much, but that's how you can build it up. And if you're debugging, like when I was building the model up, you use the equations and you see try and trace through what terms was I missing when I was building up the model. Anyways, that's it for this demonstration.